Hi friends, this is Prem Asim and welcome to yet another coding challenge. And the challenge is you need to add a number in a sorted linked list. So let me just explain you first the doubly sided linked list and then I'll take you to code. So you have been given a linked list which has all the elements in sorted order, and we need to insert element based on the sorting order without disturbing the sorting. So let's do coding. Here is our, the sample input, and you have been given a number, and then you need to add it wherever it stands, like wherever. So 45 would come before 55. That's what our aim is. So we have the test case ready. We have all these elements in the linked list. This linked list is created by me in some of the previous challenges, right? So this is a custom linked list, not the one from java.util. Linked list. So we have this method which would do the sorting. So how to go about it? So we would go first, like we need our current node. So we would say that our current node, we would say current is our very first node. Now we would try to loop over our current node until and unless this node is not null. We would play our logic. So what's our logic? Our logic is first we would need to compare the data for the current and the element. So let's say your element so whenever you are having the data which is greater or equal to the element which has been passed, that time you might need to do this. Fine. Now you see that whenever you are inserting this, you would loop it over. It would compare with each item. As soon as it get 45, it should come in between. That's what we are trying. Now how to insert it there? So we need to make a new node, right? So what we would do, we would say we are trying to make a new node which would be of new node, and then based on our constructor we need to pass three things. First is the previous node, whatever is the previous node. So the current previous would be our previous, then our data, so whatever the data which is passed to the method, and next would be our current node. So what are we trying to do here is let's say this comes here. This is our current node, which is kind of greater or equal. So we would insert it here, and then we would make sure that whatever the new node, its next node is current node and previous node is current's previous node. So it would sit in between. Now we also need to make sure that this node is pointing this. So instead of pointing this, it should point to our new node, and then that is already pointing here, and its previous, instead of pointing this, it should point to our new node, and it's already pointing there because we made it point to these. So let's correct those settings. So we have got the new node. Now from the current node we have to point the previous of the current. So current nodes, previous nodes, next node is supposed to be new node. So again I say your current node's previous node is and there could be a chance that if this is the first node, previous might be null. So let's have a null check, defensive coding. So we would say if current dot previous is not null, then we would set this thing. So this is done. Now your current node's previous, like your current node previous is supposed to be new node. So your current node previous, instead of pointing this, you're pointing to whatever the new node you're trying to insert. It's simple. And then since this is in this loop, you need to make sure that each time you're changing your current node to the current dot next. That's how the iteration would happen. So we are all ready. Let's run this and see if it fails, or and bingo, we are able to do it. Now let's test it with, let's say, number 15. And this worked fine. Let's test this with number 5. And this works fine too. Now with 1, it might have some issue. Okay, this did not show up here, right? Because you need to check your this thing, the first. If this is the very first element, how would you handle? So that's a corner case. So we would, that's the corner case. It's a coding challenge for you. We will cover that in the coming challenge. See you. Bye-bye.